Okay, number 6 on the review, we have this polynomial inequality. And we do have a hint here that you won't have on the exam. So notice here it does tell us we have to have a sign chart or graph of this polynomial function. So one of the common mistakes on this kind of problem is a student just takes this inequality symbol and just applies it all over the place. You can't do that to find your answer. We do have to look at the sign pattern of this actual polynomial. So on a problem like this, first thing we want to do is we want to find, we can call them key numbers or boundary points. They are the x-intercepts, but we need to find those important values first, and we're going to do that by factoring. When we have 4 terms like this, we want to try factor by grouping. So we're going to look at what do these first 2 terms have in common. And it looks to me that from those first 2 terms, our greatest common factor would be a 9x squared. If I factor that out, 27 divided by 9 is 3, and x cubed divided by x squared is x. So I have a 3x left behind from the first term. Negative 18 divided by 9 is negative 2, and x squared, we took out all of those, so that's all we have left behind there. And my second 2 terms looks like I could factor out an 8. And when this leading term is negative, I do want to go ahead and factor out a negative 8. Negative 48x divided by negative 8. Oh, wait, I can go higher, can't I? Look what I found here. Okay, so 48 divided by 8 is 6. Let's say I didn't notice that. And then 32 divided by negative 8 is negative 4. But look, these two still have a common factor of 2. So I was wrong. My greatest common factor is not going to be negative 8. It's going to be negative 16. And 48 divided by negative 16 is, or sorry, negative 8. 48 divided by negative 16 is 3. So we're left behind with a 3x. And positive 32 divided by negative 16 is minus 2. There we go. Now factoring by grouping worked for us because we got a common result here. So we pull that out. That's now our GCF. What's left behind is 9x squared minus 16. That is the difference of 2 squares. So we need to factor it one more time. So that factors into 3x. Square root of 16 is 4, so 3x minus 4 and 3x plus 4. And this is when we want to take each one of these factors. You cannot just set each factor less than or equal to 0. It doesn't work that way. We are going to take each one of these factors and set them equal to 0 to find those x-intercepts or our key numbers. So here we get x is 2/3. Here, we're going to add that 4 to both sides. We get x equals 4/3. And on the last one, we're going to subtract that 4 from both sides. So we get x equals negative 4/3. These are our 3 boundary points, our 3 key numbers. We're going to put those on a number line to look at the sign pattern of our polynomial. It's not important to get these to scale, but we do need them in order from smallest to largest. So negative 4/3 is the smallest value, and then 2/3, and then 4/3. If you don't feel comfortable with those fractions, you might want to change them into their decimal equivalent. That might help you on the number line. 2/3 is the same as 0.6 repeating. And 4/3 is the same as 1.3 repeating. So that might help us. Negative 4/3 is negative 1.3 repeating. That might help us when we're choosing our test values. Then we want to put our factors over here to the side. We have 3x minus 2, 3x minus 4, and 3x plus 4. And we have to choose a test value for x in each one of these intervals. In this first interval, I need something smaller than 4/3, so I'm going to go all the way down to negative 10. I know that's small enough to be smaller than 4/3. I need something between negative 4/3 and 2/3. I like 0 because that sometimes simplifies our calculations. You're a little bit careful, something between 2/3 and 4/3. Again, maybe looking at the decimals might help. I'm going to choose x equals 1. That's the only whole number between those two values. And then something bigger than 4/3, I'm going to go with positive 10. Again, just to make sure it's way bigger than 4/3. That's good. I take each one of these test values and plug them into these factors. You can kind of do that math in your head, on your calculator, whatever works best for you. If we plug in a negative 10, we get negative 30 minus 2, which is definitely negative. Plug in negative 10 to the next factor, I get negative 30 minus 4, also negative. Plug in 10 to our last factor, we get negative 30 plus 4, which is still negative. Plug in 0, and I get 0 minus 2, which is negative, 0 minus 4, and 0 plus 4. Plug in a 1, I get 3 minus 2, which is positive, and then 3 minus 4, which is negative, and then 3 plus 4, which is positive. And when I plug in 10, I'm going to get positive, positive, positive. Now, what we're interested in is that overall sign. If I were to multiply those signs in the column, first column is negative times a negative times a negative. If I multiply those together, I would still end up with a negative result. In my next column, I have a negative times a positive. So that time the negatives are going to cancel each other out and we end up positive. Third column, I have a single negative, so my result's going to be negative. And in the fourth column, I have all positives. So my original inequality was less than 0. We were looking for when is this polynomial less than or equal to 0. Less than or equal to 0 is going to be our negative intervals. So I go up here on my number line and I see my first result is negative infinity to negative 4/3. I do want to include that endpoint with a square bracket because we are looking at less than or equal to. Then I also have a negative interval, this third one, which goes from 2/3 to 4/3 on my number line. So that's going to be my other interval part of my answer, 2/3 to 4/3. Again, square brackets because of the equal to on our inequality. There is our result for number 6. Okay, number 7. This is now a rational inequality. Polynomial inequalities like number 6 and rational inequalities like number 7 both require a sign chart. Again, you won't have that hint on the exam, so make sure you understand what kinds of problems involve a sign chart. For this rational inequality, before we can start finding any key numbers or anything like that, we need to get one side of our inequality to be 0. So my first step, I'm going to add 2 to both sides. When I do that, I have my fraction 4x over x minus 3 plus 2 greater than 0 once I've moved that 2. Then I need to get a common denominator over here. I need to combine these two fractions. So I need this 2 to have a x minus 3 in the denominator. If I'm going to do that, I also have to multiply the top by x minus 3 to get that common denominator. Once I do that, they both have x minus 3 on the bottom, so I can just do the arithmetic. I get 4x plus, I'm going to distribute that to 2x minus 6. And then combine your like terms. I end up with 6x minus 6 on the top, x minus 3 on the bottom. And this is what I'm going to use to do the rest of the problem. Okay, our key numbers come where the numerator is 0. So I take the top and set it equal to 0, add that 6, and divide. There's one of our key numbers. Or where the denominator is 0. Add that 3. Those are my two key numbers I'm going to use in my sign chart. Put them in order from smallest to biggest. And then we put our factors over here on the side. And we need to choose some test values, something smaller than 1. I always like to use 0 when I can. Something in between 1 and 3, and something bigger than 3. You don't have to use my exact same test values, but you do need to make sure you choose something from the correct interval. When I put a 0 in for x, I get 0 minus 6, which is negative, or 0 minus 3, which is negative. When I put 2 in for x, I get 12 minus 6, which is positive. 2 minus 3 is negative. I put in x equals 5, I get 30 minus 6, which is positive, and 5 minus 3, which is also positive. To get our overall sign, you think if you were to multiply the signs in each column together, what would your result be? Our first one, negative times negative, gives us positive. Our second one, positive times negative, gets negative. And our last one, positive times positive, is a positive. What were we looking for? We were looking for what intervals are greater than 0. So those would be our positive intervals. Strictly greater than means we don't need any square brackets. These are all going to be parentheses. So we include on our number line from negative infinity to 1. And we also include on our number line from 3 to positive infinity. Okay, number 8. Determine the domain of this function and put our answer in interval notation. Okay, the domain of a function a lot of times can be all real numbers. We can plug anything for x and do our calculations. The two things that we have to look at that we need to consider in this problem are the domain will not be all real numbers if we have a 0 in the denominator, because division by 0 is undefined in math. And the domain will not be real numbers if we have a negative value under the radical symbol, because the square root of a negative number is undefined in math. So we kind of have the idea of all real numbers in our head, but we have to watch out for any errors that could come into play based on our function. So let's talk about the square root first. The square root of a negative number is undefined. So we have to take whatever expression is under our radical symbol and make sure it's not negative. If we want to make sure 2x plus 30 is not negative, that means it must be greater than or equal to 0. This is going to give me the good values, the domain for that radical. So I'm going to subtract 30 from both sides. Then divide both sides by 2. So if x is greater than or equal to negative 15, that radical will be defined, will be in good shape. The other thing we need to look out for is if we have any zeros in our denominator. Okay, so our denominator is x squared plus 3x minus 28, and we want to make sure that is not equal to 0, because that would be undefined if it were equal to 0. So this is a nice little quadratic. We're going to factor it. X squared splits into x times x. We are looking for factors of negative 28 that add up to 3. Let's see, 28, 1 times 28, that's not going to do it. 2 times 14, no. 3 times 8, no. Yeah, 3 times 8 doesn't make 28, it makes 24. 4 times 7, how's that sound? That sounds better. 4 times 7, and if I make it a minus 4 and a plus 7, that should work out for me. So that's our factoring. We take each one of those factors. We have to make sure x minus 4 is not 0, because that would give us an undefined function. We have to make sure also that x plus 7 is not 0. So x can't be negative 7. So we have all our answers here, but we need to put these 3 circled pieces of information together into a single interval notation answer. Okay, I sometimes like to look at it on a number line to see exactly what's happening. Okay, so if we are saying, let's say negative 15 is down here, negative 7 is maybe there, and 4 is there, we are saying that our answer cannot be 4, so that's an open circle, excluded. Our answer cannot be negative 7, open circle, excluded. Our answer can be negative 15 and anything bigger than that. So we shade to the right, but remember, we just kicked out negative 7, so we stop there. And then we keep going, greater than, greater than, greater than. We stop at 4. We kicked that number out, and greater than, greater than. So it keeps going. That's what our answer looks like on a number line. The interval notation to match that number line, closed circle is a square bracket. We stop at negative 7 to kick it out. It's not part of our domain. And then we include all the numbers between negative 7 and 4, but we stop at 4 to kick it out because it's not part of our domain. And then we need all our numbers bigger than 4. There is our domain in interval notation. Number 9, find the equation for the function that is finally graphed after the following transformations are applied to the graph of y equals x squared. So first of all, make sure you have the right parent function. We need to include x squared in our function, okay? Then I like to just work through these step by step. If it's going to be shifted to the right by 2 units, that means we're going to have x plus 2 or minus 2. To the right is actually a minus 2, and it is inside the function. Horizontal, shift to the right, is inside the squared part of our function. So that would be the first transformation. Next up, we want to reflect about the x-axis. Reflecting about the x-axis is a vertical change. That would be a negative sign outside of our function. And then finally, we want to take this and shift it down 4 units. So that's going to be a vertical change. So our last step is have that minus 4 out there at the end. Now, this negative sign did not affect the shift down because of the order of these transformations. Okay, if these two would have been switched, we would have had a little bit different work here. But this is what we get for the order that we were given in number 9. Number 10, similar question. This time, though, notice we're looking at the square root as our parent function, okay? So we want to, again, just look at these step by step. First, we are going to reflect about the y-axis. So reflecting about the y-axis, that is a horizontal transformation. So that negative sign is going to be not out front like it was in the last one, but inside our function, inside the square root in this case. Next, we're going to stretch vertically by a factor of 2. So vertical change is outside of the radical, and stretching by 2 is multiplying by 2. And lastly, we want to shift up 5 units. That, again, is a vertical change, so it's outside of the radical, and it is a plus 5 here at the end.